Awesome. Well, welcome everyone to our Astronomer Fireside Chat. So you see we brought the fire and the wonderful wilderness animals. Here with me today is Will and Ken from the infrastructure team, and I'm Aaron, head of infrastructure at Astronomer. And we just wanted to kick this off as a exciting dialogue about data engineering. So I think the best place to start is, what does data engineering mean to you? Will you kick us off?
So for me, data engineering is the part of the data pipeline process where the data engineer will take the time to set up connections between different data stores. They'll set up pipelines from different sources. They'll clean and sanitize the data. They'll be aware of what technologies are the most pertinent and the most performant. And this really is all about clearing up time and making the job of a data scientist much easier to actually build the models that the company really wants.
Nice, nice. Ken, how about you?
He pretty much covered all the topics I wanted to say, but basically for me, data engineering is the process of moving your data from your sources to your sink and trying to get that movement, as effectively, as fast as you can, so you reduce the amount of stale data that you have. And it also gives you the chance to, sanitize and marshal the data into its final format. If we can get the data into a format the data engineer wants to use, they will spend less time changing it how they need it if we can do it on the fly. So they can literally just connect to their sink and start data engineering.
Awesome.
For science.
Yeah, and sciencing, right?
Yes.
Like, I think that the industry has kind of struggled with the terms data scientist and data engineer, and I feel like they get thrown around pretty willy-nilly, and I feel like it's a really good opportunity for us. I'm glad that we started off with defining those right up front. Because I think that a lot of people are they say, oh, you're data scientists, you're data engineers, and they're just getting data, and then it kind of stops, and there's a magic box, and they just say, like, this is the data box, and, we know that people can instill value from the data inside that box, and somehow. I think that what we've been working on here for the last couple of years at Astronomer is that that's not true. Like, even if you did have this magic box, that doesn't immediately guarantee that your projects are going to be successful, or your insights are going to be correct, or even if you know the right questions to ask.
Yeah.
Right? So one of the questions would be, why is data engineering so important now? Like, why is now the right time? Ken, would you kick us off on this?
I'd say it's because we're just generating so much data every day, and people are starting to realize that there's more data in just our general activities. If you look at people like tweeting and going on Facebook, in the past you've only really cared about what were they tweeting about, what was the context, and today we're now getting into the point where we're like, well, where did they tweet from?
Sure.
Who did they tweet to? What time did they tweet at? How long did it take? How long did it take to write?
Right.
How many likes did it get? We're starting to be able to build these complex data models off of all this data we didn't know we had, and we're starting to ask questions we didn't know we could.
Right. So is this kind of like the inflection of taking your business logic and your business data that's been around for years, that we've been, we're backing it up, we're storing it now in data warehouses, but now there's the supplemental data that we can actually use to drive even better insights, and whether, like you were describing, as like sentiment analysis.
Yeah.
Right? Are our customers happy with the products that we're launching, and the customers unhappy with those products? Will, would you tell me a little bit about some of the tooling? Like, what about real-time message ingestion? Like, how do we get this data in real time and start processing it?
Yeah, so there's so many different tools, and that's one of big challenges for data engineers, is trying to pick the right tools for the job. So a couple popular data ingestion tools would be an example. Apache's Kafka is a big one. Amazon's Kinesis. And all these tools have kind of like niches they're very good at. Like RabbitMQ might be another one.
Okay.
The one I'm most familiar with is Apache Kafka.
Sure.
And really what Kafka is all about is optimizing, I kind of think of it like as the in-between space between like data stores. So you have all these different data stores. You have like real-time monitoring. You have the databases the data scientists want to get data out of. You would be collecting stuff for billing maybe. And what Kafka does is it provides a fault-tolerant way to ingest large amounts of data, retain it and back it up for a certain amount of time, normally like a week or so, but it changes a lot by what product you're working on, and then share that data to a multitude of different places.
So instead of the race to get data immediately into a system of record, so you have a transaction on your website, someone's purchased something, that gets stored into a SQL database somewhere. Now we kind of can hook in taps, right? And so you think of it as you kind of have a tap off of your Kafka stream or off of a topic, and you can say, go ahead and hit the system of record. Let's persist our business data, our transaction, but let's go ahead and pass that down the line to maybe a machine learning algorithm or off to an analyst BI team, so that they can, their tools can process it, and then maybe they can look at that with something like Tableau or Chartio. So the data doesn't have to stop in a data store into a system of record and go there to die, essentially, right? And be stale. And then one of the concepts that we've been talking around a lot is that data in motion is the opposite of Newton's law of objects in motion tend to stay in motion. It's that data in motion tries to do everything in its power to just stop and end up in a system of record somewhere. So one of the things that really has come up is, and Ken, field me on this one, but or work with me on this one, but why is infrastructure such a critical piece to this data engineering component?
It's really a critical piece because the infrastructure is what your data is going to flow through. There's lots of new tools and new technology coming out every day. You're building on top of, Amazon's Kinesis. You're building on top of Apache Kafka. Your infrastructure is what's going to be running this. So you need to make sure that you have a robust enough infrastructure that it can handle the multitude of messages that are coming through, handle the possibility of a stream failing, of a connection closing, and just, God forbid, Amazon East going down like a couple Sundays ago.
Right, yeah. I think that one of the things that really shows up a lot in our discussions with companies is that there are so many tools. Like if you go out and start looking at data engineering tools, I think there are so many acronyms. There, you've got Spark, you've got Kafka, you've got Druid. You can just keep going on. The list keeps going on. You've got
Luigi.
Right. Like we could do buzzword bingo all day here. People could buzz the door all day too, right? But one of the things that's really important to know is that you need operational expertise, right? And if you start picking out every new cool piece of technology, operationalizing that becomes very difficult for an organization. I think that opens up a door and the possibility of failure and outages, right? That if you've operationalized or you're trying to operationalize 3 or 4 new technologies, it's not like the days of switching from SQL Server to Oracle or from Oracle to MySQL.
Like a single migration.
Right. This isn't a single path. This is a new process altogether, right?
Yeah. So like selection is definitely becoming a bigger part of the job. So for example, like a fresh startup might jump immediately to Kinesis for their data messaging pipelines because the service is like pretty simple to set up and it's very effective.
Okay.
But as the company grows and they need to configure for more things, they might need to pick up a more robust system. Develop them. There's a lot of engineering overhead that goes into it to configuring it and keeping it running and keep operationalizing it in the first place. But once it's up and running, it'll be a better tool for the job. So that's a big part of what an infrastructure team needs to do is the R&D, just look at how the company's going to scale so we can understand the amount of bandwidth and how robust our systems need to be.
We were talking before this, going over about Apache, Kafka, and Amazon's Kinesis, and Will, you even brought up that I didn't even think about this. Kafka can have as many consumers as you want on a topic. Apparently, Kinesis can only have 5.
Oh,
right. Yeah, and I know the numbers change pretty frequently, but I think that you run into some architecture issues very quickly with some of the cloud-based tools.
Right.
And what you find is that the more money you throw at the problem, you seem to start being able to ungate things. But when you start working with tools like Apache Kafka, or whether you're using any kind of other like RabbitMQ, it's really up to you to kind of start building those components and defining those service level indicators of, how many messages can we send through, how many operations can we process, how durable do we want those messages to be.
Right.
One of the things you were bringing up about, in conjunction with Kinesis here is cloud-based versus on-prem. And I feel like those are some really, that obviously changes the game up for data engineering. When you're a cloud-first company, you have a wealth of tools that you can have at your door. But when you start talking about running on a traditional IT-based organization's infrastructure, I feel like it definitely changes the dynamic, right, Ken?
It does, because at points like that, if you are doing stuff on Amazon Kinesis and you now need to go on-prem, you've lost Kinesis.
Sure.
You've lost all of the cloud-provided services that you were using before. So while it's the benefit of Kinesis and things like that is it's allowed you to get up fast. It allows you to get going quickly. You just give a credit card and you've got it. It's very inflexible. You are kind of tied in to where you are at. And even like switching to a different provider, be it Google or Microsoft, they may not have the similar product, or it may work totally different.
Right.
That's why your infrastructure should really be able to look at other options and try to plan ahead to be like, is there a chance we could get locked in and we're going to get, pay for this in the long run? What if we end up wanting to sell our product to a company that is on site only?
Yeah, I feel like, with the change in the business ecosystem right now, with a lot of these insight-first products, where making sure that systems of insight are actually the spearhead, it's the tip of the spear for these organizations, being tied down to one provider or one particular tool, that lack of agility, in the beginning you're like, wow, we can go to market quickly, but like I agree with you, the operational overhead to either migrate off of that tool, sometimes you never do. And we've seen a lot of this, if you look back at the days of, the IBM AS400,
yes.
Like so much work was put into these these heritage systems, right? And they still power many of the interfaces we see today. It's just that they've been abstracted away. But what I would say, my piece of advice would say, work heavily with your teams, your IT teams in your organization. Right. If you're a large organization, you're trying to operationalize your data engineering, the sooner you get corporate IT involved and start understanding, what it takes to operationalize a new tool and a new tool set, it helps gain success for a project, right? It's always awful when you have a shadow IT organization that has been buying a service in the cloud with with marketing's credit card, and then they magically get caught. And then they have to, kind of fess up and be truthful. And they're like, hey, we've been running in Azure for 6 months now. And then, corporate IT's pulling their hair out, going, we don't even know, right? Where's compliance? How are we handling any kind of backup and recovery?
Authentication, user access, and are you keeping track of people when they log on?
Mm-hmm. I think it's definitely the game's changed, right? It used to be, IT controlled all the keys to the kingdom. Now, there's a weird power struggle going on, but I think that they're still very important. There's still a wealth of knowledge of compliance and regulation and security, because data breaches become extremely expensive, and it's what stopped companies from moving forward and actually being a system of innovation, right?
Right.
Because why would I roll out this new mobile app if the potential to lose customer data would reflect negatively on our stock price, right?
And even speaking about that, I think it's also starting to bring to light the fact that we need to bring more security into our data warehouses and whatnot, because you look at a lot of the latest security breaches, and it's like, they got the whole database, okay, but then they also got plain text information. Why was this, not encrypted at rest? It's a lot of new databases and warehouses today are supporting encrypted data at rest.
Right.
And it might be a little more hard to implement, but it could save your company in the long run.
Right. Well, you were talking about data engineering with preparing these tables. Do you see a value in allowing data engineers to, apply rules, strict data governance rules to data sets to make them easily accessible by data scientists?
So you mean something along the lines of like access control groups for different positions within the company?
Absolutely. You've got access control, as well as anonymizing data sources. So if you use a third-party consultant to do some of your data analysis, you don't want to hand off your pertinent customer information.
Yeah, so that'd be like a very useful division of labor between a data engineer and a data scientist, is letting the data engineer go ahead and scrub and clean and anonymize any data fields that need to be cleaned before passing it off. And along with that, I'm not 100% sure. I guess it would depend on the org whether or not this is more of an infrastructure or data engineering job of assigning like access control groups and making sure like maybe only like the chief data scientist of the company can have access to this very unanonymized data, whereas different groups will have access to exactly what they need to see. And by separating that workload off the data scientists, again, that lets them be more productive with building the models the company actually wants.
I think you've hit home to something. There's something I want to circle back with. It's a complex problem. It's not clear cut. It's not IT handles access control to the data. It's not data engineers do this. It's not data scientists do that, right? One of the things, and we're going to have our assistant on the other side here. Steve, is there a way that you can send this out to the folks in chat here? So we did a white paper, and this is data engineers versus data scientists. And it's not that they're trying to go at each other. This isn't dev versus ops, right? Like data scientists and data engineers are complementary. But Steve's going to send this out to the channel for everybody to take a look at. But knowing just some of these fundamental principles kind of helps understand that there are separations of concerns, but there are definitely some blurred lines. Your data scientist should be a heavy lifter of moving data, And with tools like Apache Airflow is a really great one. For example, Airflow enables your data scientists to start doing very data engineering focused tasks, right? They can build new core tables, they can move data around, they can schedule tasks in a dependency driven manner.
And then that will also kind of break their dependency on the data engineer, where if they're like, oh, I'm really getting into this problem really deep, and I just need this extra piece of data, instead of having to get with the data engineer, possibly write up requirements, write up a timeline, if they have something like Airflow, they could write their own, well, we call them DAGs, but they're basically a Python script that helps them pull the data and marshal how they want. They can do it themselves and run it themselves.
Oh, like a directed acyclic graph, right?
That's it.
Right. So it's a dependency-driven task definition.
It allows you to basically set up, pull data from this source, marshal this into here, convert into this schema, load into table.
Sure. So,
and if data scientists can easily pick up on that and easily change their data on the fly.
Right.
And if infrastructure can get all that set up, that's just something that can be handled automatically.
That's a big advantage to the pretty recent advent of infrastructure as a service, where you still need people for a large organization to manage the entire thing, but when it comes to just getting started and letting the end users of the tool be able to play with it very quickly without having to operationalize it on a big scale, makes it easier to facilitate communication between the scientists and engineers and the infrastructure.
Absolutely. Yeah. So one of the terms we've talked about a lot internally is data democratization, which is the concept of, data engineers build these core tables to the best of their ability, but a data engineer is not always the person with the most context for a business line. So, just as you would have, 5 or 6 disparate business lines throughout an organization, maybe you could have 100 for, depending on your size. Most of the knowledge about the business unit happens way down at on the BI, the business intelligence team, business insights team, further down the line. So it's kind of up to the data engineers to provide these primitives, like try to hit 80% of the target of data that they need, and then allow those BI teams and those data scientists and these analyst teams to be able to carve and manipulate that data and start enriching it. But what we want to start seeing is more companies contributing that data back. Right. It's been awful when you hear about the stories of people that have been, they spend, half of their month is building a report that is printed out in a PDF, and they have to go back next month and build the same report again, and they do this over and over and over again. And I think this falls in line with, data scientists are spending 80% of their time massaging and manipulating data and getting it into the correct format before they actually can do that 20% of insights. And we want to be able to have them contribute those insights back up into the Hadoop cluster and or their data warehouse, right? It doesn't have to be Hadoop, but they could then give these back and then allow the data engineering teams to provide clear lines of governance and access control and kind of corporate policy. And so as data scientists are giving this data back up into the org, data engineering and corporate IT kind of work to battle harden those data sets so that they don't change.
Yeah, and basically prevent them from overwriting data that they really probably shouldn't touch.
Okay, so let's go in and let's do a couple of minutes of Q&A. I know that Steve's been fielding questions for us here, and we'd love to hear from the audience for sure.
Sweet. So the first one is, where is the market moving in terms of data warehousing philosophies, data lakes, data marts, S3 versus Redshift? Will the enterprise market standardize on an approach?
Okay,
that's a good one.
Wow, I can tell you that every organization is different. I've been in a number of different organizations here recently, and they're all at different levels of what we call the data maturity mountain. And in that data maturity mountain, you're trying to at first you have nothing, you know nothing, and then you know nothing, Jon Snow, right?
Yes.
And then you turn around and you're starting to aggregate this data, but you're not drawing any insights. So I think your first stop is you have to crawl before you can walk, before you can run. So implementing some form of cloud-based data warehouse strategy, I think makes sense for most organizations that aren't operationalizing that today, right?
Yes.
And then if you continue down the line, depending on how your organization is built, maybe bringing that in-house and running an on-prem version of your data warehouse, then it starts turning into it starts evolving into these data marts where the BI teams are really being explicit on the data insights. As the format of the data is tightly controlled and presented in a very structured way, so that once again we kind of follow this 80% rule, right? Where 80% of the insight should just kind of be there,
right?
And they should be off the truck. right? So when you hire a new data scientist, they should be 80% efficient, you hope, right?
You hope.
On day one, where they can go and they can kind of talk to that data mart. I think that that's really where the market's going, is that, at first let's aggregate it and get it in, a data lake is obviously one of your other solutions where you're just throwing it all in there and
we'll touch it eventually.
Right, but it's definitely moving in this direction of powerful BI organizations. Powerful BI teams are really driving these organizations to define or be defined is always one of the principles I always say. Like it also falls into the be explicit over implicit. So we're going to explicitly state what we want the data structure to be. Yeah. Now we're always open to feedback, right? But at first, let's make a decision. This is what the data is going to look like.
So I would say that additionally there are new tools coming out that are making it easier to move away from data lakes, namely real-time stream processing and things like Google Protobuf and Avro kind of let you apply structure to your incoming messages, which makes it easier to keep it in a structured store rather than throwing it all in one place and hoping to be able to use that stuff later.
Gotcha. Yeah, you're not passing the buck on later down the line for the next person that's going to take over your role, right?
It's almost like we started building these data lakes because we didn't have the tools to handle the data at the time and do with it what we want. Mm-hmm. Now we're starting to get it, so we're seeing people starting to extract the data from the data lake and move on to things like Redshift and other highly structured databases.
Sure. Steve, what else we got?
Two more. So the next one is, can you talk about one or more easy to discuss use cases where the Astronomer system provided a strong ROI?
So this gets pretty abstracted away from what we do, because most of the time we spend a lot of time focused on servers and not really tied to a customer name. One of the things that I would really say is we've been involved in a couple of organizations where their data that was coming in was actually structured incorrectly. Yes. So they were storing, so they thought they were collecting all of this data, and what happened is, it was separate from the data science team. So IT and data engineering was kind of, or anointed data engineering, right? Like someone who accidentally fell into the job, right? They defined these data structures, and they thought, we know what the data is supposed to look like, and they started building these data models early. What we found is that when applying Astronomer into their organization and really making it easier to access that data from a data scientist standpoint, we actually found that empowering these data scientists, they really quickly shot holes in the bottom of their boat for their design of their schema, and they found that one, data was transformed incorrectly. They were using the wrong math behind that. That's out. So that's the science portion of it, right? Yeah. But also that they found that they could be a lot more efficient in structuring their schema in the long term. So what would have taken an analyst 2 to 3 weeks to finish a report because the data and the data was actually wrong.
Yeah.
Another thing that I actually found interesting is one of our customers had an issue where data was being pulled from a warehouse every morning to build a report, but it was set up in a scheduled cron job that happened every night at midnight. So the report was generated automatically. It wasn't dependency driven. So data didn't get replicated over one night, and it was more than one night. It was multiple nights, so the data was wrong. And so they kept generating these projection reports, and then ultimately they found out, oh no, the task to do this migration of data over from our system of record to our warehouse was not firing. And so that's one of the things where Airflow allowed them to trigger based off of the detection of that job being completed.
Right. So they weren't no longer creating reports on stale data.
Right.
And not realizing that it wasn't happening.
They could they were sending alerts as well, where if that data didn't happen, then it would trigger an email or a text message or open a ticket in their support system, or alert somebody with pingdom. Yeah. I know that they were doing some form of alerting, but with that alerting, then they could wake up whoever was responsible for the original job and to make sure that job was complete. Steve, one more?
One last one.
All righty.
So oftentimes the raw data contains insights that process data users. Do you expect the data engineers will identify that information and provide it to the data scientists?
Ooh. Will?
So this is actually a use case where Apache Kafka is very useful, because you don't necessarily have to process everything, and normally, one of the Kafka is like a big octopus that sends data to a bunch of different sources, and what a pretty common use case is to move the raw data somewhere to sit. Let the engineers and the scientists process the data they want, mm-hmm. and then they can kind of wait up until the retention period of the log Kafka maintains to see if they want to go back. or if they think there's something good there that they're missing, they can move it to a data warehouse and let it sit for a while and then return to it later. So just because things are being processed in real time doesn't mean you're losing the original data.
It's like it's the concept of using an immutable state, right? And this is we're seeing programming models and functional programming all over the place now, where the message shouldn't really be transformed or changed. The message can, insights can be driven off of that message. You can output a new transform off of it, but the original message stays intact all the way through.
Right.
I think that it's pretty awesome that you apply that with Kafka. I think one of the other things is when we're building out core tables, we shouldn't be doing heavy transforms. We shouldn't be presenting these heavily opinionated tables first. They should be built up of smaller, less opinionated components, more of the primitives behind the scene. So we should make our data warehouse should be more composable, as opposed to having one stop shop for customers, and customers will always look like this.
Yes.
Like customers might be 5 or 6 different data sources in the raw form, and we should make those available as well with tools like Airflow.
So a very common example of when you would do this is if you're processing text data, what's a very common real-time processing enhancement you can do is you kind of maintain the original text, but then you also provide the data scientists with tables of word counts that you can process in real time, because doing it in a batch is very time consuming,
Okay.
but doing it in real time is very simple, and then you can have that enhanced data alongside the original.
Oh, awesome.
So you're basically pulling data out of the data that you already ingested. You're already pulling your insights out, but we're not losing the original data, so we can always go back to pull additional insights.
Awesome. Well, Steve, I think is that all we had for questions?
One last one.
In at the end. Come on in, bring it home.
Can you turn off the beeping?
Oh. So right now we have someone power washing our building. All right, and we, even opening the window and yelling out at them, they don't care. Data engineers have no authority over the power washer guy.
I think he's just having fun on the forklift.
Yeah, he's been going up and down. So no, we apologize for that. We did our best to try to yell him down. Unplugging it felt really unsafe. I think there's an OSHA violation that we're reporting right now. He didn't
get his jacket on until he was about 3 stories up. So.
Right. So, we do have one more question. All right. Sure.
So what does Astronomer provide above and beyond a traditional ETL platform?
Okay. What does Astronomer provide above and beyond a traditional ETL platform? Okay. Astronomer should be your core fundamental platform for data engineering. And what does it provide? In a traditional ETL sense, you would see more of an IT ETL tool would be, make sure this task runs every day at 3 a.m. Alert us if it doesn't happen. What doesn't happen in these traditional tools are these dependency-driven access. But what we would say, Apache Airflow is a task runner, a pipeline tool for data scientists and data engineers by data scientists and data engineers instead of coming down from the top from IT.
Right.
Then when it comes to our real-time streaming and ingestion processing, right? I feel like our opinionated workflow on Kafka and how we integrate with Apache Spark for processing those messages gives us like an unfair advantage as well, right? Like, so we've got what we consider the new stack, and the new stack would be a containerization tool. Yep. So in our particular case, we use Apache Mesos, but you could use your containerization tech of choice, right?
Exactly.
And then combine that with a workflow scheduler. In our case, it's Apache Airflow. Then with real-time stream processing, so you've got Kafka and Spark, and we're using Spark streaming. Those really go above and beyond because now you can get down and dirty with traditional batched ETL, and then you can get into this new real-time, almost they call it micro batching, if you will, right? But we're considering it real-time of data processing.
Right.
So we can actually take traditional, non-real-time streaming sources and start funneling those into Kafka or into Spark, and actually drawing real-time insights based off of those tables. So.
Right, and we're kind of making the complete platform, like you said, for data engineers.
Right.
We don't want to be just a single tool. We want to kind of be the entire platform where you can, using our platform, just connect to source, connect your sync, connect your sync, and we have all the tools and all of this insight on how to get your data through the system. Right. And of course, just multiple ways of hosting it, be it if you want it on the cloud, you own VPN, or even on-prem.
Right. Yeah, I think making sure that we have an opinionated stack is what the most important part is. Because the tools, there's so many tools that we have available to us today, and making sure that we have core expertise operationalizing the tools that we've talked about today. And many times you can start bolting things on, and you know, those become liabilities. For us, you know, our core stack that builds Astronomer today is something we have extreme operational efficiency in. So, all right, so I think we're going to wrap things up. I know it's been a long time hearing us chat here on our nice inaugural Fireside chat. We'd love to have more conversations with everybody. This is not an easy problem to solve. There are a lot of moving parts. There are a lot of problems that require, you know, more brains than what are here in the Fireside today.
Oh, yes.
But if you'd like to have more conversations with this, we implore you to reach out to us at astronomer.io, and would look forward to seeing you on more of these Fireside chats. Take care.